So we know from the power iteration video that once we have the wave function, we can obtain the energy level by multiplying the Hamiltonian matrix by our wave function. And that'll give us the energy levels times the wave function. That was easy to do with the built-in matrix sub-VIs, but we need to write a special matrix multiplication because we have our matrix in this tridiagonal form as these three different arrays. Okay, so this matrix times this vector gives us this. F0 times wave function 0 plus G0 times wave function 1, so on. So we want to make a for loop here. We need to read all of our values of our arrays. And we're going to go through one row at a time here. And we're going to first do F0 times psi 0. So I need to use an index array here. So I can grab a particular index of the wave function. And I'm going to end up needing, for every row, the I index, which will start off as 0, and the I plus 1, and in most of the rows, the I minus 1 as well. So we'll always have the three kind of neighboring points of the wave function. So I'm going to go ahead and read the I minus 1 and the I plus 1 at the same time. And we're always multiplying. I can just auto-index these because I only ever want the I value of those. So we're only using the 0 subscripts of the E, F, and G values here, only the 1 values here, only the 2 there, and so forth. So I can just auto-index them. I want to multiply the F value always by the same index of the wave function. Okay, so I want the I index, and I want to multiply that by F. The E value should be always multiplied by the I minus 1 index of the wave function. And for this first row, you can see the I minus 1 would be the -1 index, which doesn't exist. It won't exist here either. But if you try to read the -1 index of the array, it will return a value of 0, which will just cancel out that term and be exactly what we want. The G value is always multiplied by the index of the G plus 1. So we can always multiply G by the +1 index. And then we want to add those three terms together that we just multiplied. So I'll use the compound arithmetic sub-VI to easily sum those three numbers. And this resulting vector, when we auto-index here, oops, wire this better. When we auto-index here, we'll get a vector which will be this. And the way that we got the single energy value is we multiplied this by our wave function. Once again, we're basically going to do a dot product projection here. And sum the h times psi sum all of that, and we should get the energy level, assuming our wave function is normalized. If you want to make sure this works even if the wave function isn't normalized, we can just add one more step here where we take psi, we square it, we take the sum, oops, it's not where I want that. We still want to multiply that by the wave function. But we want our final number to be divided by the sum of the squares of the wave function. All right. So these are your inputs. This is your output. And that's all there is to it.